Good morning, student. Welcome you all in the video practical session for the subject of illumination and electrification of building. Today we are going to see experiment number 2, which is based on measure the illumination output of different lamps and compare it with their wattages. So different lamps are incandescent lamp, fluorescent tube, and compact fluorescent lamp, that is CFL. Before we are going to start this practical, I again remind you that please take a note on old journal page or any notebook, that is write down for the experiment number and its title, aim, observation table, objective learnings or learning objectives, and conclusions. And along with that, keep your uh, attention regarding this experimental for your future. So let us start with this experiment. Its prior concepts are type of lamps, illumination level by different type of lamp. In proposition 1 for the good illumination scheme are: it should provide adequate illumination. Whatever the lamps are used for over the working plane, it should provide adequate illumination, that is sufficient illumination all over the working plane. Then it should provide uniform illumination on all working plane, that is similar illumination at various working plane or any particular plane or surfaces. It should avoid glare as well as shadows as far as possible. Due to this, quality of works are expected. It should have a good color rendering effect. Due to this, objects discrimination of objects are easily understandable by that human being. The next proposition is luminous efficiency. It should have high efficient, so that can the lamp or fittings which are used for the working, which are get high efficient and high economical. So take a look for the energy distribution of incandescent lamp. This is how the energy of incandescent lamp is consumed and radiated. So if 100% power electrical energy is consumed by that incandescent lamp, then it will give the output in terms of various stages like radiation and non-radiative losses. So radiations are 82% and non-radiative losses are 18%. In that 18%, power losses are 18%, and in radiation it gives infrared radiation, that is 72%, and visible radiation and 10%. It means out of 100%, visible radiations are given out by the incandescent lamp is 10%. Next one is energy distribution of compact fluorescent lamp, that is CFL. If CFL consumes 100% its input, that is electrical energy, then it produces non-radiative losses as well as radiations. So in that non-radiative losses, 38% losses, out of that power losses are 42%, and additional 4% from the discharge radiations. In discharge radiation, out of 60%, it gives infrared radiation 36% and visible radiation 20%. So in that CFL, 22% of radiations are available for the user end, which is more than the incandescent lamp. Now the learning objectives. Understand the requirement of good illumination scheme. The next is understand the comparison between incandescent and compact fluorescent lamp with respect to life, lumens, depreciation, spectrum of color rendering and cost. It means how we can adopt good illumination scheme for the working areas, as well as depending upon the different types of lamp fittings or lighting fixtures, lifespan of all the light fittings are very different, and according to that the lumens and the power consumption, the depreciation also varies. So as more efficient lamps are there, then the lamp life of that lamp also increases. If the lumen output are very low, then depreciations are very high. So there is need to compare the lumen output and depreciation of various light fittings. So according to that we can select the type of lamps for a particular application. Now the motor skills, nothing but a performance skill, which are after conducting this experiment you will be able to connect the equipment as per circuit diagram and handle the instruments. Ability to observe and record a luminous flux. Now the apparatus required for this experiment is lux meter. We have a digital lux meter, and second incandescent lamp, it's 60 watt 230 volt AC, CFL 8 watt 230 volt, fluorescent tube 40 watt 230 volt, auto transformer 0 to 270 volt, watt meter 300 volt 5 ampere 1500 watt. So with this equipment and components we can connect or prepare the circuit as per this diagram. It shows the connection arrangement for the incandescent lamp. It is connected across the auto transformer as well as voltmeter. Wattmeter is also used to measure consumed energy by that incandescent lamp. These all the connections are connected for the 230 volt single phase AC supply. So you have to draw this diagram in that page as a connection arrangement. Second connection diagram shows for the compact fluorescent lamp, which is little bit difference. That is, instead of using incandescent lamp, we have to use compact fluorescent lamp only, and remaining the connections are same as per the previous. So here we are conducted the experiment on fluorescent tube by connecting this circuit diagram here for the CFL as well as for incandescent lamp. Now the readings are, when we are kept the lux meter light receiver away from the 1 meter from incandescent lamp, then it will measure the lux level, that is 202 luxes 1 meter away. When we kept this lux meter 1 meter away from that lamp, here this lux meter is kept for the CFL and it gives the reading, that is 63 lux level of illumination. Next we are using fluorescent tube and the lux meter shows the reading, that is 65 lux level of illumination. Then now the observation table It shows the observations regarding the consumed power and level of lux. For the incandescent lamp, 100 watt incandescent lamp used over here, and it gives 202 lux level. Fluorescent tube, 40 watt power consumed, and it gives 65 lux level. CFL we are used over here, 9 wattage, and it gives lux level, that is 63. Now the conclusions from this experiment, we conclude that there is a different illumination level from different lamp. Also we are able to compare illumination and wattage of different lamp, so that can it will help to us that is use select the different type of lamps according to their applications as well as the color of a room, so that can efficient illumination schemes should be adopted. Thank you.